Today you'll be learning how to prove that lines are parallel. And yes, you'll have to do some proofs with this. So let's look at some of the postulates that they're going to provide for us to help us prove that lines are parallel. So the first one is postulate 16, and that's the corresponding angles converse. So basically it's going backwards from what you learned last time. You used corresponding angles. However, now you're going to use the converse. So if two lines are cut by a transversal, so if you'll see I have my two lines A and B, if they're cut by a transversal, this line going through here, then the lines are parallel. And what has to happen there is you have to know that the angles, the corresponding angles, are equal. So if you have two lines and they're cut by a transversal and angles 1 are congruent with angle 2, then you know, yes, it is parallel. Because basically it's saying that this one is going at the same slant as this one to provide those equal or congruent angles. Okay, let's look at a couple more. And make sure you're writing down the postulates. If you want to print these out too, if you can do that as well. Okay, there's three more, and I'm not going to go through each one and use the proof, but it's basically like what you looked at before in the last page. So alternate interior angles converse. So if you have two lines and you draw a transversal through them, then those alternate angles, if those are equal or congruent, then the two lines must be parallel. Same with the consecutive interior angles converse. So if you have your line right here, your two lines, and then your transversal going through it, if these two angles are supplementary, which means that they're going to equal 180 degrees, then these two lines must be parallel. And the other one you're going to look at is alternate exterior angles converse. So if you draw your two lines, you cut it by a transversal, and your alternate exterior angles are congruent, then the lines are parallel. So you can use all four of these in your proofs. So make sure you get those down. And let's look at a proof. So proof of the alternate interior angles converse. And you can use this as a guide for your other proofs. So it says prove the alternate interior angles converse. So they're saying prove that if you have two lines and you cut a transversal through it, that the alternate angles are going to be equal to one another. So we're going to start with angles 1 and 2. So my step 1 was just to write the given, which is that angle 1 is congruent to angle 2. Now I want to get down to prove that lines M and N are parallel. So what they did was in step 2, they went from 1 to 2 to 2 to 3. So their ultimate goal is to prove that 1 and 3 are equal, so we need to include 3 as well. So what they did is they used the vertical angles theorem, which, remember, states that angles that are vertical from one another are equal. And then what they did is they said if 1 equals 2 and angle 2 equals 3, then you can use that transitive property saying, remember, 1 equals 2, 2 equals 3, so 1 must therefore equal 3. So here they use the transitive property, the algebraic one we learned. And from that they got down to that alternate interior angles. So if you look, 1 and 3 are alternate interior angles. And so then they prove that lines M is parallel to line N. So those are some proofs you're going to look at, and I'll walk with you through them during class. I'll see you then. Bye.